Okay, welcome plant science students here. Last video, we ended up just finishing up talking about the electron transport chain and how the electron transport chain makes ATP and it also makes the NADPH. That is going to be going over then to the Calvin cycle. So our goal today is you're going to be able to describe the general process of carbon fixation through the Calvin cycle. Carbon fixation meaning you're fixing carbon or changing carbon into an actual usable source for energy, okay, which is simply our carbohydrate. And now we're going to be talking about the Calvin cycle. So we finished this here. We talked about NADP. A hydrogen ion is then carried over and added to the NADP to create NADPH. So NADPH and then ATP that is formed in this chemiosmosis is going to then be going into the Calvin cycle. So right here, ATP, NADPH, going then into the stroma of our thylakoid or of our chloroplast, and we're going to be going and talking about carbon fixation. So what is carbon fixation? Again, simply the process which forms organic compounds from inorganic compounds through carbon-carbon bonding. Carbon comes in, and we're fixing it, changing it into a usable energy source. So here is our equation. I wanted everybody to just kind of do a little refresher here on what the equation is for photosynthesis. So here it is. Grana simply stacks of thylakoids. Thylakoids are inside of the chloroplast. Stroma is kind of the substance, intermediate substance that is kind of surrounds the thylakoids. Photosystems are inside of the thylakoids, and this is where the electrons actually were in the electron transport chain. Light-dependent reaction, we already talked about that. The electron transport chain releases oxygen, makes NADPH, chemiosmosis makes ATP, and carbon fixation is simply, again, process which forms organic compounds from inorganic compounds, are simply changing carbon into a usable source. So let's get into the Calvin cycle. This is the Calvin cycle here. I'm going to go back to that last slide in a second. But here's the Calvin cycle. And we'll go back to this here. So what actually occurs? This first part here is the general process of the carbon fixation. Calvin cycle occurs within the stroma. We have 3 molecules of carbon dioxide coming in. Rubisco is an enzyme, attaches the CO2 to the RUBP, ribulose biphosphate molecule. So we have 1 of these, and then the 5 carbon, 5 plus 1 equals a 6 carbon molecule compound. It is very unstable and immediately splits into 2 3 carbon compounds, which we call them phosphoglycerate or 3-PGA. So here we are. We have carbon dioxide coming in. This Rubisco enzyme takes this, adds it to this right here to create a 6, count 1, 2, 3, 4, 5, 6 carbon compound. Immediately splits in half, so we get 2 of these phosphoglycerates. We then add some energy of ATP comes in. We add a phosphate group, boom, right here. NADPH comes in. This right here, and this right here is right here, ATP, NADPH. That's where it comes from, electron transport chain. NADP, a hydrogen ion comes in here, adds phosphate group is dropped here from this here. These then ADP and NADP plus and this phosphate all go back to the electron transport chain, and then this is a continuous cycle that is these are recycled. They come back then as ATP and NADPH, but this is just a continuous cycle. We go from this 3 here, phosphate group drops, to then create this glyceraldehyde 3-phosphate, okay? It's, again, a 3-carbon compound. So through this process of carbon fixation, reduction, and then regeneration, so we go from 6, divides in half to 3, phosphates added, phosphates dropped. Then we get this glyceraldehyde 3-phosphate, which this is pretty much the intermediate carbohydrate. 2 of these together, so this cycles 3 times. Okay, we have 3 carbon dioxides. 1, 2, and 3. We get around a couple times. We put two of these together to create glucose. The other remaining one is then recycled back to RUBP, a 5-carbon compound, and then the cycle just continues on. Glucose is made, or any other organic compound, mainly glucose, though that's the energy source, and then it is go ahead and recycled. So again, we talked about that. The glyceraldehyde 3-phosphate, or the phosphoglycerate is converted into 1-glyceraldehyde 3-phosphate. Call it G3P or PGAL, but a common term is, so PGA gets converted into G3P. It's like Star Wars, sorry. But in turn, we get, we also have 6 ATP and 6 NADPH that are going to go ahead and give up that phosphate group, like I said. And then ADP and NADPH is, recycled back to the electron transport chain. And we get 1 molecule of glyceraldehyde 3-phosphate. Again, Rubisco enzyme helps attach carbon dioxide to this RUBP, creates a 6-carbon compound, splits in half to create phosphoglycerate. ATP and NADPH are added here to help this cycle go. We get a glyceraldehyde 3-phosphate, and then the cycle continues. And the last one, regeneration, is when that last molecule is then regenerated back to RUBP for more carbon to go ahead and bond with it. So that essentially is the carbon, or the Calvin cycle, founded by Melvin Calvin. He was the one that discovered this. This is actually how a plant, it's in the stroma, this process happens. Molecules are bonded, unbonded, put together to pretty much create this glyceraldehyde 3-phosphate, and this bonds then together with another glyceraldehyde 3-phosphate to create glucose, which is the sugar, which is the energy source for the plants. Now, the next chapter is cell respiration. This is actually where we take the glucose molecule and then break it back down, kind of in a reverse process, to create ATP molecules. Okay, efficiency-wise, it's just the process. It's how it works. So why do plants, again, what do they do with the sugars they make? It's fuel for the cell. It's fuel for the cell. This sugar fuels every part of the cell, and that's what we'll talk about as the chapters go on here. So next, the part 3 is just kind of finishing up, talking about factors that affect photosynthesis, getting into that. But hopefully this was a little bit of information on how this Calvin cycle actually works and how glucose is actually made.